Today we're going to finish our Chapter 5, Lesson 2 notes. We completed the most challenging problems in class. We still need to complete problem numbers 2, 4, 6, and 26. If you have not done so, I'd like for you to pause the video and I want you to attempt those 4 on your own first and then play the video to see the final solution. Okay, problem number 2, verify each identity. And I need secant squared theta times the quantity 1 minus cosine squared theta to equal tangent squared theta. I notice right at the beginning, we have 1 minus cosine squared theta. That is a Pythagorean identity. So I have secant squared theta times 1 minus cosine squared theta is sine squared theta. Next, I'm going to put everything in terms of sine and cosine. Secant squared theta is 1 divided by cosine squared theta. I'm going to keep sine squared theta and make it a fraction by putting it over 1. We multiply fractions straight across. So 1 times sine squared theta is sine squared theta. Cosine squared theta times 1 is cosine squared theta. This represents a quotient identity. Sine squared theta divided by cosine squared theta is equal to tangent squared theta. Problem number 4. Okay. There's no GCF. There's no Pythagorean identity because none of the expressions are squared. So I'm going to make the left side equal the right side by first putting everything in terms of sine and cosine. So cosecant theta is 1 divided by sine theta. And cosine theta will remain cosine theta, and I'll make it a fraction by putting it over 1. And cotangent theta is cosine theta divided by sine theta. Always multiply before we add or subtract. So I have 1 divided by sine theta minus cosine squared theta divided by sine theta. I have a common denominator, so I can write this as a single fraction. My denominator is sine theta. My numerator is 1 minus cosine squared theta. 1 minus cosine squared theta is a Pythagorean identity and is equal to sine squared theta, all divided by sine theta. When you divide exponents with the same base, we subtract the powers, so sine squared theta divided by sine theta is equal to sine theta. In problem number 6, I have tangent theta cosecant squared theta minus tangent theta, and I need to prove that it is equal to cotangent theta. Okay, I see right away that I have a greatest common factor of tangent theta. So I'm going to factor out the tangent theta first. So tangent theta cosecant squared theta, all divided by tangent theta, would leave me with cosecant squared theta, minus, and tangent theta divided by tangent theta is 1. Okay, cosecant squared theta minus 1, this is a Pythagorean identity. Okay. I know that cotangent squared theta plus 1 is equal to cosecant squared theta. So if I subtract 1 from both sides, I'll get my cosecant squared theta minus 1, and that would be equivalent to cotangent squared theta. So I have cotangent theta times cotangent squared theta. Now, there's a couple different ways I could approach this from here. I know using the reciprocal identities that tangent theta is 1 divided by cotangent theta times cotangent squared theta divided by 1. Okay, this is equal to cotangent squared theta divided by cotangent theta if I multiply straight across, which is equal to cotangent theta. You could have also put everything in terms of sine and cosine, and you would have gotten to cosine over sine, which is cotangent theta. I guess it would help if you could see the entire problem. So again, Pythagorean identity. I used the reciprocal identity and made tangent theta 1 divided by cotangent theta, multiplied straight across, and simplified. Okay. Our last problem is problem number 26. So go ahead and turn the page. Okay, in problem number 26, we have tangent squared theta, cosine squared theta, and we need that to equal 1 minus cosine squared theta. Well, I'm going to begin by putting tangent squared theta in terms of sine and cosine. So this is sine squared theta divided by cosine squared theta times, and I have cosine squared theta all divided by 1. I can reduce cosine squared thetas, and this is equal to sine squared theta. And using the Pythagorean identity, I do know that sine squared theta is equal to 1 minus cosine squared theta, which is what I was trying to prove. Again, this is using a Pythagorean identity. All right, I'd like for you to go ahead and open up your textbooks and begin the homework from Chapter 5, Lesson 2. Again, feel free to message me if you have any questions, but better yet, please stop into SRT or pop in the morning, and I'm happy to go through this with you in detail. Good luck.